Hello,
Hello, everyone.
welcome back to the result.
Yes.
So, in case you weren't here for last week's stream, we put out a print challenge to print uh, these cubbies, and yeah, today we'll be going over what everyone did, what we did, how we approach a challenge. But I think before we jump into that, uh, I'll introduce myself again. I'm Mateo. I'm one of the co-founders of 3DQ and joined again by Leah.
Yes. I'm an
Yes.
intern at 3DQ.
Yeah.
Have been here for like 2 months now.
2 months now. Yeah. And this is like your fifth stream,
Yes, yes, yes.
something,
Probably.
maybe even more.
Maybe. Can't really remember at this
Yeah.
point.
Too many to count. Yeah. So, if you hadn't seen, last week we put out a challenge and to ourselves and to our community to see how many of these cubbies we could print. And yeah, I guess we might as well just dive pretty much right into it because it's time to show the result.
Yes.
Okay, so here's what we've built, but this is actually only like 1/3 of the total parts we printed. So we sort of we ended up I guess underestimating just how many parts we would get. Um, so here there are about, I think, 70 parts.
Mm-hmm.
In total, we printed over 150 of these rods and over 200 of these shelf pieces. Leia, do you want to
Mm-hmm.
show like
Here's like the rectangular
here's the
parts.
rectangular parts.
Could pour them all over the table, but that'd probably
Well,
hurt your ears.
yeah, we can say that for later.
Yeah.
And then
And
do you want to show
then,
the rods?
yes.
Yeah.
Move those actually. And then these.
There you go.
Ta-da!
So many pieces. It's kind of ridiculous.
Yeah.
Um, so in terms of our setup, I'll pull up some videos here. Um, let's see, where are we? But we set up, actually, why don't you talk about the setup, like our Quinlys,
Mm-hmm.
how we printed this when we started, while I pull up some videos that we can
Yeah,
look at.
sure. So we have three printers going in the other room, basically, and they all have our pie cams kind of watching them as well, just to see if there's any failures as we printed, which we had some good ones, so I'm pretty happy about that. And yeah, we did basically, I think we did more of
Oh,
the
this,
square parts because that we need more of those, but we probably overdid it on the tall connecting pieces just because we were printing a lot of everything and we ended up just having too many of everything
yeah,
to even build.
like we totally were not expecting to have this much. So we started printing Monday afternoon right after the stream, and I think the last parts I collected were from Sunday evening. So this was two of the printers we had set up. The actual setup had three shells. Uh, VLC's being a little silly.
That's
Um,
fair.
yeah, just some shots of like all the parts being printed. It's kind of crazy. Like, yeah, here's the setup. So we just had
Yeah.
these three printers sitting on the wire rack shelves. We were printing pretty much non-stop over the course of 6 days. Um, and the only downtime we really had was um, one printer did end up failing because the probe offset was changing too much.
Okay,
And then
that's
the
fair.
the other one was like anytime it was stopped, it was usually due to us just running out of filament. So I
Yeah.
think in total we ended up using doing one filament change. So we ended up using about 6 kilos
Oof.
of material. Yeah. So here you can see kind of it was a very, very rudimentary setup, but
Mm-hmm.
like we pretty much slapped it together in an
Yeah.
afternoon just for this challenge. And yeah, we were able to make nearly 400 parts. just like completely hands-free, which was super cool. But then on Sunday evening when I came in to start
Building it.
building it, it was yeah, not super fun.
That's pretty fair. You looked a little depresso in those
A
videos.
little bit depressed. Yeah, it was yeah, it's a lot more work than I think we bargained.
Yeah.
Um yeah, so I guess what we'll do on this stream is talk about basically what our strategy was, how we approached this, because I remember during the last stream some of the viewers were actually started printing right during the stream. But what we ended up doing is spent a bit of time after to slice so that we could optimize for print
Hmm.
time. And then I think ultimately that's why we got such a high yield of parts, was because we were, even though we took a bit of extra time up front, um, we ended up printing these much faster than we would have if we just used our default profile.
Yeah, that's fair.
Um, yeah, so that was like, yeah, that's actually a very important strategy for printing for production, and it's something that we use um, pretty much everywhere. Like whenever we have a really large print job, whether it's printing parts for our Quinly kits,
Hmm.
or sometimes we get like there's one job that we've consistently had with drunk engineers where we printed now, I mean, well over probably close to 10,000 parts for
Yeah.
them. Uh, and yeah, investing that time up front and making sure your slicing is really good
Hmm.
um, pays massive dividends. Um, so yeah, why don't we run through the actual uh, slicing process? I'm
Yeah.
gonna
Move it.
maybe put it like this so it's
Okay,
not
that's a bit
blocking either of
better.
us.
That's fair.
Yeah, and if you guys in chat have any questions about like how we printed so many parts, or if you want, if you've got Quinly or if you're running printers for production, if you have any specific questions about slicing, we'll be going through that now. So definitely post your questions in the live chat where we'll be looking at it and responding live as well. Um, yeah, okay, let's switch into Cura. So, uh, why don't we start with how we printed um, the rods?
That sounds good.
So we did actually talk about it a little bit last stream, but I'm gonna pull up the rod model. Okay. So with the automated printing, you like the most ideal way to get quality is by printing one part at a
Hmm.
time, um, because you don't have excess retractions or excess travel. And it is actually something to consider when optimizing for time as well, because when you have a plate full of parts, like if I were to just add, 20,
Oh
which will
my God.
fit, you actually have all of these retractions and travels
Yeah,
in between the parts. And that adds up to be a lot of time.
that makes sense. I didn't really think about that.
Yeah, the sum of it is actually like greater than just multiplying this one
Mm-hmm.
part by
That makes
20.
sense.
Um, and the other thing that gets affected is your part quality, because now you
Mm-hmm.
have all of these excess retractions happening when they normally wouldn't have.
Yeah.
So that's just something to consider when doing it.
Mm-hmm.
That being said, we did actually decide to run these in minor batches,
Mm-hmm.
because one thing to think about is with automation, you have your heating time and your cool down time. And so when you have really fast parts like this, for example, this part, 14 minutes.
Damn.
That is, that's, hold
Extra
on, I'm in the
fast.
wrong profile.
Yeah, I mean, it is called really
Yeah, that's
fast.
the really fast profile. That's not the one that we used. Oh,
I mean,
I think this is the one that we used.
there
And we'll go through very specifics. So it's about, yeah, this makes more sense.
we go.
So it's about 46 minutes. But if you're printing one part at a time, you might have 10 to 15 minutes of reset.
Mm-hmm.
And so now you're extending your part time by 25%. So in a lot of cases, what we find is doing small batches,
Mm-hmm.
which keeps the failure risk low, um, but doesn't add too much travel and retraction time, actually ends up being the most optimal way to print this. So what we did was we were printing them in batches of 5. Let's see. One other thing that we did, and I'll show you actual video in a second, is space them out.
Mm-hmm.
Uh, that's just because sometimes when you have two walls really close like this and you
Yeah.
get stringing, the parts can actually get joined together. And
Not ideal.
yeah, it's not ideal, especially
Okay.
because we were printing so fast. So
Yeah.
we allowed like a certain level of stringing was
Yeah.
acceptable. Um, so we just had to separate the parts because then you wouldn't get stringing between these parts.
Yeah, that makes sense.
Yeah. And then again, that's like, I guess moving on to the next step is when you are printing this many parts,
Mm-hmm.
like you have to also think about what your post processing is gonna look like. So though we were pretty time constrained on getting it running pretty much like within a couple hours after the stream.
Mm-hmm.
Um, One thing that we did do that I think could be improved next time is we actually used a skirt on these. Um, and something that we do a lot um, when doing lower volumes and it's not worth coming up with another solution is you do a skirt that's a zero point 0.4 millimeter distance, so like your nozzle distance
Mm-hmm.
away from the part. And what this does is it makes it very, very easy to remove the skirt. It's almost like a easily detachable brim.
Yeah.
Um, but you still get all the benefits of priming with the
Mm-hmm.
skirt. So let me
That
see if I
makes
can
sense.
pull up a video that actually demonstrates what I'm talking about here. Probably one of the part release videos. VLC, please. But let's see if I got a part release video here somewhere.
Ooh, close.
Okay, I think right around here. 27. All right,
There we
sweet.
go.
Let me just switch views. Oh my God. All right, here we go. So this is how it actually came out, and you can see the vapor bed, which is really cool, has actually already released the middle part
Mm-hmm.
when it got
Yeah.
cold, and then because of the angle, it's already like trying to
Perfect.
escape. Um, but here, so you can see there is a brim or this skirt with a
Mm-hmm.
very minor distance. And you'll see it actually it's close enough that it'll get pulled off with the parts. But then that gap that we leave makes post-processing really easy because you just pick it off.
Yeah.
But yeah, in an ideal situation, I think if we were gonna do this again, which we are kind of talking about
Yeah.
doing, we would try to go for no skirt and maybe something like um, a priming blob in the middle of the bottom surface itself.
Mm-hmm.
So what I mean
That's
by
fair.
that is like inserting custom G code
Yeah.
where the nozzle will like sit in the middle
Mm-hmm.
and just print a blob and then you print the first layer on top of it.
Yeah, that makes sense.
Yeah. So like yeah, it's very, very helpful to do that. And we've done this in the past with our face shields. So when we were printing a few thousand face shields, we didn't want to, well, our first iteration had skirts just like
Mm-hmm.
this. And because of their shape, they would always hook into each other.
Oh.
Yeah, if you think about
It's a
it,
bit
like
annoying.
it was pretty bad. Um, and so they would like hook into each other into the skirt. And it just made post processing them a nightmare
Yeah, that
because
makes
they wouldn't
sense.
like sit flat in a box
Mm-hmm.
and they would just get tangled up. And
That's super annoying.
yeah. Oh yeah, here's one. Thank you, Steven. Yeah, so it was like this,
Mm-hmm.
and then there used to be in our first iteration a skirt going around it, and then these little hooks would hook
Mm.
onto the skirt. It was pretty bad. Um, but what we ended up doing is uh, coming up with a solution where um, we embedded. I don't know if it shows up on camera. Probably
Sorry,
not.
can maybe do like the picture-in-picture focus?
Yeah, can you zoom? Oh,
Oh,
it's zoomed on,
hello.
please.
Oh, it's doing this weird.
Oh my God.
It's almost there. Yeah, there
Oh,
you
There we
go.
go.
sweet, got it. Okay.
Yeah.
So we had to embed these I guess product numbers onto them, and we actually used the product number as our priming line. So what it would do is there's G code at the top of the file that we inserted that did these letters, and um, as it did the letters, it primed the nozzle,
Mm-hmm.
and then it would just afterwards print the first layer of the print
That makes sense.
right on top of it, and it you got this really beautiful effect where you actually got the part number embedded right into the that's the
First layer.
bottom layer, yeah. And so you can do something similar um, here with some custom G code that just inserts a dot or a blob, and then you can get rid of your skirt entirely. Um,
There was a question about how wide the skirt and how far it was from the part.
so the skirt was 0.4 millimeters, which is just the nozzle distance, and then you can do as many lines as you like. We usually just do two or three. Um, but yeah, when doing really high volumes, um, I probably spent around 2 hours this weekend post-processing all the parts.
Mm-hmm.
So coming up with an alternate solution, such as a prime blob that then gets embedded into your part, um, is definitely the way to go. And even though it does take um, a little bit more time to set something like that up,
Yeah,
it will save you so much time in the long run. So
that's pretty fair.
yeah, like I know with these headbands, it literally saved us days of post processing just because there was so much skirt removal going on
Yeah,
before we switched.
that's
So
very worth it then.
yeah,
Good, they're still on Cura Viva.
yeah, I'm just showing
Okay.
the slicing.
Also, there's another question about if the parts had any variation from the beginning to the end of the run.
That's a really good question. Um, so our profile that we used for this, and this is something we'll talk about in the improvements. Um, one of the things we wanted to do was just print as many parts as possible.
Mm-hmm.
Um, and so we used a very fast and very coarse profile. And something that I did notice is on the enders, the Z offset would shift over time. And then that was the main cause of part variation. The parts themselves, discounting the first layer,
Yeah.
um, are all extremely consistent. Like it's hard to tell where in the batch one came from when they're all
Mm-hmm.
mixed up. Um, but if you look at the Z offset, we noticed it was shifting a lot, and that's something we've noticed on the 8-bit enders a lot. Um, and it's kind of hard to determine. I don't think it's a probe. We did a ton of probe testing in last year. Steven was actually doing it, Steven behind the camera.
Mm-hmm.
Uh, yeah, I don't believe it's our probe. I think it's actually a limitation of the 8-bit firmware.
Makes
When
sense.
it mesh levels, it can't do um like the calculations it's capable of are not as good as on a 32-bit
Mm-hmm.
board. And so I think part of it is inconsistency in the mesh leveling itself. And then part of it is just heating and cooling and doing so many cycles over time. Just heating and cooling, doing those cycles causes the printer to move and settle.
Mm-hmm.
Um, One other thing that happened last week is we were just coming out of a massive heat wave.
Yes.
And so the ambient temperature in our office, because you can see, I'll go back to the setup. Um, the temperature in our office, and this wasn't in our production room. This was just in our um in
Like an
just
office
like an
room.
office room, like our one of our R&D rooms. Um, the temperature fluctuated quite a bit, and I think that has to do with it. As it got cooler over the course of the week,
Yeah.
the Z the Z offsets could change because the printer itself is physically a different size because of the
Yeah.
ambient temperature. That's why it's so critical to make sure that wherever you're setting up your machines is relatively stable in terms of ambient control because you'll notice ambient temperature differences will manifest in your print, not
Mhm.
just in terms of surface quality, but also in terms of the printer itself will have to be calibrated a little bit differently. So that's a super good question, and yeah, it is definitely something that we noticed. Um, you can see this was taken on one of the hottest days, and then we had a fan blowing air out
Yeah.
of the room just because it was so hot and because this room was not climate controlled. Um, all right, I'll go back into Cura and then we'll talk about some more specific slice settings. So, um, the way we did it was we were doing zero point 0.8 line width because we were trying to print very, very fast.
Mhm.
And actually the layer height that we used as well was quite high. It was 0.4. And the reason that we could push the layer height so high was because in terms of this model, the layer height actually doesn't make too much of a difference.
Mhm.
Do you mind grabbing one of the rods actually, and I'll show. But the exposed end of the model, thanks, is the bottom side of the rods, and the layer height is not going to affect how that looks.
Yeah.
The line width will a little bit, your nozzle width, but if you're just looking at this bottom part and the rest is structural, your layer height doesn't really matter because all you see is this
Yeah, that's
first
fair.
surface. And luckily the vapor bed has a really, really nice glassy finish.
Yeah, it
So
does.
so it wasn't too big of a deal. Again, maybe going forward, if you were building this for aesthetics, I would consider doing something like concentric infill for the first layer. So that's like top initial layer concentric, because then you'd get a really nice bottom pattern that's
Mhm.
facing you. You can see the concentric pattern looks far better than just lines. So that's something when we do more shelves, and we'll talk about this later, is something that we try out. Yeah, so in terms of other settings, when you're doing high layer heights and a big nozzle width, you also have to print really, really hot. So even though these were PLA, we were using temperatures of 235 to 240 degrees.
Oh,
Yeah, so which
didn't
is
even
like
notice that when I was watching the printers.
quite hot. Yeah. Um, and part of that is because you're extruding so much plastic at
Yeah.
once. But the other reason is that the hotter you print, the stronger your parts will be. And because these are flexible components,
Mhm.
they need to be really strong. So a high layer height and really hot layers helps with strength quite a
That
lot.
makes sense.
Um, the other thing to consider is the orientation of the parts. So your layers are stacked in pretty much the worst way possible for a part where these prongs need to bend in and out. Each layer line is basically a weak point in that.
Mhm.
And so that was another reason that we wanted to um, print really hot. Yeah, that basically for part strength.
Yeah, that just makes sense.
If your parts are weak, then you printed like hundreds of really weak parts, and
There's no point in
yeah,
that.
your yield will be really, really low. So it's about thinking not just I think with normal printing, a lot of people take the mindset of how do I just get this model to come out good?
Yeah.
And then you'll do whatever slicing you need to do. But when you're doing printing for production, like we do here, and like
Hmm.
our many of the Quinly users do, um, you have to think about not just how it'll print and how it'll affect the print time, but all the other steps post printing,
That makes
post processing. Do I print with a skirt, or do I invest time coming up with a way to print with no skirt? Um, what level of, in our case, we wanted to print really fast, so we said, well, the strings, if they're stringing, especially in these parts, you can see these gaps. If you're
hmm
printing too fast, you'll get a ton of strings. And so what we said was, well, these are not visible and they don't mechanically impact the parts, so we're
Yeah.
okay with having these strings here. Um, and we're not going to be worried about post processing. So that
Yeah,
was
that makes
also
sense.
something to think about. And it's just all of the trade-offs. Um, they have to think about during printing and post printing,
Hmm.
because yeah, even though we had our kind of basic skirt solution, which is just removing
Yeah,
skirts easily, um, I still had to remove dozens of skirts from parts, and that takes time.
for sure.
Um, but yeah, now we know. For
Yeah.
next time, if we're gonna print any more of these, it'd be worth investing the time to print without it.
Yes, a very good experiment at least.
So I'm gonna open uh, the other part of this challenge, which
Hmm.
is, so these are the connector pieces that you can see, and then there are the actual shelves,
Hmm.
and those parts are really good because a lot of people ask, oh, how does Quinly work for really flat parts with
Hmm.
higher surface area? And I'll show you a video now. Um, Let me just pull up a video of the part removal for that. And uh, first I'll show off the part removal, and then I'll talk about why we laid the parts out the way we did for production. Um, okay, here
Here
it
we
is.
go.
So just switch scenes. All right. So here's how we laid the flat shelf parts. Maybe if you can grab some, Leah,
Yeah.
from our box of dozens and
Here's a
dozens.
bunch.
Thank you. And so you can see we actually did print them with a skirt. But the skirt comes off with the parts.
Hmm.
But you can see it's very, very, very loosely attached as well. Um, yeah, I'll just skip forward. Oh my.
Oh. Next one. Next
Next one,
one.
next one. There we go. So you can see that the release is pretty much perfect. They just slide right off.
Hmm.
Because a lot of people are like, oh, are you shoving the parts off with the nozzle?
No.
No, the vapor surface completely releases the parts.
There's a reason why it comes with the vapor surface.
Yeah, that's integral to the automation. And yeah, so um, this is how we laid them out. And again, you can see that because we didn't have too much time, we just went with our standard uh, skirt system.
Hmm.
And I want to highlight here at the very end, you can actually see some of the parts that have fallen in here. The skirts have already detached.
Hmm.
And then, yeah, that's why, even though it's not uh, super recommended in terms of post-processing time, that's why we kind of stick to the skirt as the default, because it is super easy to set up
Yeah,
and it's very easy to remove. But
makes sense.
yeah, when you have, if you want to show, when you have hundreds of parts, it does get to be a bit burdensome, and then that's when you again
Yeah. I
consider.
think most of these don't have any.
Yeah, these have all been post-processed. Let me switch to the main view. Yeah.
Ta-da.
Pulled them all off yesterday.
There we go. Very nice.
Quinly for resin printers, Ben
That'd
is
be
saying.
sick.
Maybe. I would love to. It would be awesome to have Quinly for resin printers. We are doing kind of one printer at a time though.
That makes sense
Trying,
though.
trying our best, yeah. So we released Prusa 2 weeks ago, and we plan to release a couple more printers this summer. I think we might even be talking about some in a couple weeks, in 2 weeks. Yeah, so stay tuned for that. But let's go into the actual slicing for production for the flat parts.
Yeah, I thought that looked pretty cool when I was watching them print because they're like one by one.
Yes. Okay, so that's the secret sauce.
I wanted to see the secret sauce of that.
This is a technique that is extremely useful. So you know how I was mentioning earlier that so first of all, we decided to print 4 on a bed at once. And earlier I was mentioning that when you're printing batches, you have all of this extra time due to your all of your travels and all of your retractions.
Yeah.
One thing that you can do with some parts, and that we use very, very frequently in our production, is Cura's print one at a time feature. So if you go into, I think it's in special modes. Yeah, print sequence one at a time. What this does is this is super cool.
Literally never seen this before.
It's very, very cool. What this does is it lets you, well, it's basically 4 individual prints on the same bed. So it will print one part from the beginning to completion.
Yeah.
And then print the next part, and then print each part. And this border around here is just the gantry area. So that's so that an exclusion zone so that your nozzle doesn't crash into previously printed parts.
Makes sense.
So when you do something like this, and we love printing like this, you can see it does just one part at a time.
That's sick.
And so that's how we did it on our on this. So they were actually printed one at a time, one after the other. And so that gives you some of the benefits of batching, but without any of the risk of, or with very low risk that comes with batching. I shouldn't say without any, because you still, if a part fails out of the 4, it can impact every part after it.
Yeah.
But it's not going to impact any part that was printed before it, which is very nice.
That's fair. That's super cool.
Yeah, and you also don't have to reset 4 times. You reset once for the 4 parts.
Yeah, exactly.
For that Drunk Engineers project where we've done the tens of thousands of parts, we actually print 9 of their small pinions on the bed at once. And they print one at a time, like all 9 do.
That's sick. I like this. I'm glad I was here to see
this. I feel like it's a very underutilized feature.
Yeah, I think so.
And part of it, honestly, is that it's only really useful for production. And not that many people use their 3D printers for production.
Yeah, I guess that makes sense.
Yeah. But we use it all the time because all of our printers are set up to run as production machines. So going back into Cura, that was the big strategy we had here was to reduce print time, was reducing our print cycles, and doing, because these parts are as well are very fast. I think they're only 35 minutes each. So reducing print cycles was important with them, and also by doing the one at a time, you get rid of that extra retraction time.
Mm-hmm. That's
Um,
fair.
yeah. Other than that, the settings were pretty much the same. Again, we did 0.4 because the front edge, you really can't tell that it's a low layer height. And
Mm-hmm.
even though you see the lines, it's actually not too big of a deal. It looks kind of nice.
Mm-hmm.
Um, and yeah, I mean, our goal was just to see how many we could print. So we ended up printing
Quite a few.
quite a few. I think, yeah, over 200 of these on the
Yeah.
3 machines we had set up. Um, yeah, I guess if you guys have any questions in the live chat,
Mm-hmm.
let me know. Um, sorry, I'm just reading the chat right now. 2.85 filament. That is actually a good strategy. A lot of people, we've pretty much switched most of our production machines over to larger nozzles,
Mm-hmm.
and larger diameter filament works better with larger nozzles
That
just
makes
because
sense.
you can push way more material at once,
Mm-hmm.
and you don't need the resolution that you get with a smaller nozzle and a
Mm-hmm.
thinner diameter filament. Thinner diameter filament gives you far more control, but the if you're just looking to push, Steven's going on vacation, if it was saying bye. Yeah, smaller diameter filament gives you far more control
Mm-hmm.
over how much filament is actually coming out,
That makes
because
sense.
for one rotation of the motor, you get less material,
Mm-hmm.
or you for each step you get a smaller dot of material.
Yeah.
Um, but we found that for most applications, uh, point 0.8 works just well. Most parts that we print that we get in don't have any features on them that are smaller than 0.8 millimeters.
Yeah.
And that's really the only constraint where you would have to switch to a smaller nozzle.
Yeah. That makes sense.
Something also that we commonly do on our 0.4s is just boost the extrusion width. So then you kind of get the best of both worlds, but you need a really good extruder to do this, um, where you can actually get 0.8 line width through a
Mm-hmm.
0.4 nozzle. You just have to shove filament through it, and
Fair enough.
it actually works really well. Like we do it on the stock with the stock ender extruders.
Mm-hmm.
You just have to print really, really hot.
Okay, that makes sense.
Yeah. Um, what else is? Oh, right. Another really cool thing. If you do have a good extruder and you're comfortable printing point 0.8 out of your point 0.4 nozzle,
Mm-hmm.
you can kind of get the best of both worlds, because what you can tell Cura to do is print the infill at a point 0.8 line width. So that
Oh,
prints really fast.
yeah, that makes sense.
And then just do the outermost wall with a point 0.4, which is your
Mm,
actual nozzle size.
that makes sense.
Yeah,
Cool.
it's a super cool trick for saving time, because who cares
What's
about the
inside? Yeah.
internals? Yeah. And point 0.8 is actually uh, larger line widths, like point 0.8, and higher layer heights are much stronger
Mm-hmm.
generally with 3D prints. So
Okay.
you actually want your infill to be at a wider extrusion width, because it will just be stronger.
Yeah. It's cool.
I typically do 150% line width. Yeah, 150% is like the safe zone that you can pretty reliably do. This is a comment from Ben. So on a point 0.4 nozzle, that's 0.6 extrusion width.
Mm-hmm.
And even that saves you, um, up to 50% of time, just because you're getting more material out of the nozzle.
Yeah.
But you can always, with a small nozzle, you can always switch down to retain the quality of the smaller one. See, that is a great tip. it's one of those things that you only really discover like once you start pushing how far 3D printing can go for production.
Mm-hmm.
Um, like if you're just using your 3D printer um, every once in a while and you're not using it to like for an Etsy store or for higher scale projects, or
Yeah.
if you don't have timelines, it it can be fine to kind of go the easy route and just
Mm-hmm.
use very reliable default profiles that
Mm-hmm.
will always give you safe settings. Um, but when you're doing production, now your printer, whereas before it was constrained by your time and your availability, it's now constrained by how fast can the machine move. Um, it makes sense to really try to push the slicing settings as far as they go. Um,
Yeah.
and in the case of this project, like every minute that we saved translated to, because we have 400 parts,
Mm-hmm.
400 minutes of printing saved, or
That's
400
true.
minutes of extra printing. Just imagine if you were printing this uh, for work, like for your Etsy store. Imagine how much uh, extra money you could earn if your printer could do 400 extra minutes a
Yeah,
week, right?
for
That
sure.
Dominic, how many hours is 400 minutes?
Um,
That's like
Putting him on the
it's like
spot.
7 hours, I think. It's
I
close to
trust.
7 hours, I think.
I trust.
Yes, 6.666.
Six.
There we
Okay,
go.
so 6.666 hours. So
Thetans.
equal amount of hours.
Yeah,
Wait,
don't do 400 minutes.
yeah, don't do 400 minutes. But yeah, so over the course of this week, we printed. You should show the parts again for those who
Okay.
didn't see. Just how many? Maybe put them on the table or something.
Should I pour them all out?
I don't think it'll show up.
Yeah, I think it's pretty loud.
Dang
Yeah,
it.
it'll be
Okay.
super loud.
Here we go.
They're
See
those.
that? Oh, not that strong.
Okay. Yeah. And then all the ones here. That's a lot of parts.
Ta-da.
Benny Brady said he should have printed more benchies to go on with it.
I should have.
Yeah, we do have some benchies. We've actually found a couple of our benchies for these.
Very nice. These are our beautiful ones.
Yeah. I think these two are PLA and then this one is polycarbonate.
Ooh.
Yeah.
These almost fit inside.
Yeah. We're planning to reprint this whole thing, but larger, and then wall mount it behind us for
That'd be pretty.
for the next stream.
Yes.
But yeah, with with Quinly, it's actually feasible to fit 100 or print 100 benchies and fit them into all of the cubby holes. And we actually, uh, I guess this video will be going up in a couple weeks, but we just got a massive sample pack of different materials from one of the companies that we work with. And so we actually will have benchies to put in this shelf.
Yes.
In
That
like,
looks so pretty.
I think they sent us 12 different materials.
Ooh.
Yeah, it'll be really cool.
There we go.
There was a thought I wanted to finish before this, but oh, right. So, yeah, over the course of the week, we printed around 400 parts. And in your slicer, if you're able to save just 1 minute per part, that's translating to about 6.5 additional hours of printing you get from your printers every single week.
Exactly.
And in this case, in this particular case, where a batch of 4 is 2 hours, roughly, we would be able to get 3 extra cycles per week, which is 12 additional parts. So for every 1 minute that you shave off of your print time, you're able to get 12 additional parts.
Which is pretty insane.
I feel like that is something that once you wrap your head around volume production on 3D printing, just spending a tiny bit of time getting your slice settings optimal,
Mm-hmm.
like it pays back really quickly and um, massively too,
Yeah.
especially when you have more printers. And it only gets multiplied by the number of printers you're running with automation, with Quinly automation, and the amount of parts that you're running on those printers.
Mm-hmm.
Um, yeah, so in our case, a lot of I think the default Cura profile, actually we can, I don't have it loaded up here. I think this part with the default profile, just the one individual part, um, took about an hour and 15 minutes. And these settings that Steven implemented brings it down to 33 minutes. So over the course of the
Nice.
week, that translates to hundreds of additional
Yeah.
parts. Um, and again, it's because with Quinly, it's just Quinly in the printer, and Quinly's 24/7, so really it's just constrained by the printer.
Mm-hmm.
And you can make your printer work faster just by changing a couple settings. When you're running a print farm manually, the typical way you'd optimize for um, amount of parts and print time capacity is by either yourself being more available to manage your machines and to remove parts and to start new prints,
Mm-hmm.
or getting more printers,
Yeah.
or hiring more people to run your print farm. And so the first one is yourself, just being around the printers more. Well, you're giving up your life
Yes.
basically, which was me at one point
Sad.
in the past, which is not ideal. You only have a limited amount of lifetime
Mm-hmm.
that you can dedicate to your machine. The second one, which a lot of people do and is very, very interesting, is get more printers.
Mm-hmm.
The problem is when you're running a printer manually, every printer you add uh, increases your work.
Yeah, for sure.
So if you go from 2 to 4 printers, you've doubled your time commitment, or your 4 printers will now be running at half capacity. So it's as if well, not fully half, but will be running at a lower capacity
Yeah.
because your time has to be split among them.
Yeah.
And you're not getting 4 printers worth of printing. You actually
Mm-hmm.
get diminishing returns. And then the final one, which is hire more people to help you run more printers, that's just an increased cost, and
Mm-hmm.
the cost is linear with the amount of printers you have.
Yeah.
But what we found with printers using Quinly, um, and this is what's really interesting, is because there's no human component, your time and the cost of your time and the cost of someone else's time to run your machines just goes away. And that's already a massive cost reduction.
Yeah.
But because the printer is managed by Quinly and no longer needs um, human time, it can now run 24/7, and you don't have that constraint. So what many of our customers see is they're not only able to print more because they're just printing more hours in a day, they're
Mm-hmm.
printing 24/7. They are spending far less time on the printer. And what that's resulted in, which I think is, in hindsight, it's pretty intuitive. But what that's resulted in is many of our customers end up buying more 3D printers
Yeah.
because they now have time open to run more machines.
We got a question from Benny Brady about how we're planning to mount the shelf to the wall.
We've got these command strips here. Yeah, this is what we're going to try to use. And if that doesn't work, we'll probably, I don't want to drill holes in our wall.
It's very nice and yellow.
Yeah,
You
we've
guys
got
will
a,
see next time.
next time you'll see it, but we've got a really nice yellow backdrop on the other side of this room. Actually, you can see it for 1 second in one of the videos. Let me show you.
A sneak peek of our background next time.
Let's see. Oh yeah, okay. It's this
Okay.
video of me
Being depressed.
being depressed, walking slowly with boxes of hundreds of parts. Okay, here we go. So that's the. I was very tired. Here's our yellow wall.
Very yellow. It'll brighten our mood and our day.
And they'll brighten your mood and your day
Yeah.
instead of this gray wall. Maybe that's the reason for me looking so sad. I was facing the
That's
gray wall
could
in here.
be. There we go.
Yeah, this is the actual recording room. I've
And
also got another cool video of it's a partial time lapse of putting these together. Oh yeah, one thing I did want to talk about is we did push the printer pretty much to its limits for these parts. Um, and there are some consequences to doing that. And one of the things was, in our case, we were printing really fast and really hot, and it means the tolerances on our parts are not ideal. So if you actually look, you can kind of see that the shelf is a little bit wonky.
just a tad.
It's a
You can
tiny
see
bit
that it's
wonky.
kind of curved as well on this angle
Yeah,
too.
it sort of curves backwards, which is interesting. And part of that was because we were printing so fast and at such a high temperature, some of the edges ended up not being perfectly straight or perfectly in tolerance. And so that's something for to also try. So what we should have done and what we do when we run actual production is run a sample run of parts, maybe
Mhm.
a couple cycles, um, which in this case would be about 2 dozen parts, and test fit them. Um, and what we actually did that on a much smaller scale because that day was super time constrained, and it seemed to fit fine. But these small errors, when you expand the shelf more and more, actually add up, and it
Yeah.
just gets really. It's not too bad, but it gets a little bit wonky, and so that's something also to consider is when you are pushing for time. Yes, a minute saved can result in like 12 additional parts every single week. Um, but if your parts tolerance is too low, or if you're ending up with a higher failure rate, like
Mhm.
with parts out of tolerance, um, then it's obviously not worth it
Yeah.
because at some point in the pursuit of speed, you'll end up hitting a wall where your parts are just unusable.
Yeah.
Um, and so I think our plan with um, this and the rest of the parts that we have in the bins are going to end up being a nice little display shelf. But we found out that most of the parts we have to display are actually a lot larger.
Yeah. Bigger than the benchy.
So we'll be reprinting them. The shelf, everything just scaled up. Um, One thing that was really cool about this experiment, I'll show the shelf again, and you might notice we are running on the shelf, we're running the pie cams.
Yee.
You want to talk about what you were doing adjacent to this challenge?
Yeah, sure. So basically, I was trying to get the most out of our PyCam thing. So basically, we aren't using like just the streaming UI. I was trying to set it up to take time lapses of basically everything. So right now, I wrote a script that it's like a bash script so that it basically I mounted Google Drive to our pies and then I got it to send all the pictures every 4 hours that I took to the Google Drive. So now that we can easily look at them or we can annotate them if they actually did fail or even just like make videos out of the time lapses. So that was really interesting and they're actually going still right now. They basically continuously go unless you like stop them. So it's kind of nice that you don't have to always transfer the images like physically with a USB stick or just like
Yeah,
literally, I don't know, any other means of trying to take them out. It's nice that it's just automatically uploaded to somewhere you can just look at from your desktop. So That was very nice.
Yeah, we leveraged the fact that we were printing hundreds of parts to do some data collection for
Yes.
our failure detection, which is super cool. You can see on the right side here is the pie cam just mounted and staring at the
Tip of the
part.
nozzle, yeah.
One of the nice things also that happened, nice and not nice at the same time, is that because we pushed so hard for speed, we actually did end up with some failures.
Mm-hmm.
One of the ones that was really common was getting layer shifting, and this
Okay.
it was layer shifting in a very interesting way. It would layer shift after the first layer.
Oh, that's so strange.
Yeah.
Interesting. Okay.
The reason for it was that in Cura we it's kind of a combination of things. So one is that we're printing really fast and with uh, a wide nozzle, and we have our first layer extrusion multiplier turned up.
Okay.
So it's a zero point 0.8 nozzle with extra extrusion, really fast and really hot.
Mm-hmm.
And what that ended up doing was creating a rough surface on the first layer, on
Yeah.
the top side of the first layer.
Oh, that's interesting.
And because the printer was moving so fast, basically to the point at which the ender motors were about ready to give up, when it hit and traveled back to a previous like first layer,
Yeah.
it would hit the rough
Yeah.
top surface and actually
Okay.
cause the nozzle to chip. And it's
I
only a
see.
problem on the first layers.
Interesting.
So it's gonna
Okay.
be interesting for your model.
Yeah, I need to look through all those images. There's like, I think at least probably like 30,000, I feel like,
Yeah.
on the drive now. Gotta
Yeah.
make sure we have enough room.
That's that's one of the other awesome things. In with just 3 printers, in 1 week, we got uh photos of 400 different parts printing and 30,000 photos that we can use for training data,
Yes.
which is awesome. I think it's one of the really amazing things about Quinly is
Yeah.
you can hit these volumes, and then of course with that much training data, your model is going to end up being very robust. So I'm
Mm-hmm.
super excited. I mean, when you showed me what you had done last week,
Yeah.
it was already working.
I was already working with like what, 60 or 70 images, which
Yeah.
is like nothing.
So this one should be about what, 2,000 times better?
I hope so. That'd be ideal.
Yeah. Yeah. So with 30,000 photos, it should be pretty good, I think. But yeah, we'll be continuing collecting these images and training up the models.
That'll be cool.
So you sent the pictures from the Pi to the cloud. That's a great idea.
Yeah.
Yes. Yeah, Leo was uploading just a script that just took all the images and put them into
Google Drive.
Google Drive so that we could pull them down and use them later for our vision detection. Super. I'm so excited when we get to release this.
Me
Like it's
too.
gonna be so good. Just the volume of data that we have to train it is
Yeah.
it's exciting.
If anybody's actually interested, I'm going to be writing like a few little things on LinkedIn about like the process of collecting everything and like designing the scripts to make things fail and just like
Yeah.
a few things about that. So if you're interested in the machine learning part of it, you guys can check that out
Yeah.
sometime later.
Yeah, I'm excited to read those articles. Love to learn more about like what's actually happening.
Yeah, that's fair.
Yeah. Definitely look out on LinkedIn for that.
Mhm.
That's gonna be so exciting, especially seeing the progress. Like I just
Yes.
I'm so excited about just this jump from 60 images to 30,000
Yes,
in a
it better
week.
be insane.
And we only have 3 printers
Yeah.
running this. Like we plan to get PyChems on our production system, and
Yeah, that would
right
be
now
cool.
we've got nine printers that we're installing there this week.
Mhm.
Yeah, but I feel like our viewers will find purpose print failure. Really, really interesting.
Yeah, that was fun.
Yeah, that is so fun. Yeah, if you don't know about it from our previous streams, Leah's using the automation on the Quinlys and some custom code that she wrote to take models and cause random failures, and then use that to generate training data for our failure detection system.
Yeah.
And the best part about it is that because Quinly's fully automated, you can just print fail after fail after fail and like know what type of failure it is and then just automatically like have it basically
Exactly.
train itself, which is super
Awesome.
super exciting.
Yeah.
I have a couple Panda Pi boards that use Octoprint with a special build on Marlin to send data.
Ooh.
Be interesting. It would be interesting to try Quinly on those Panda Pi boards. I think it should work fine, but I don't know how the Marlin. We would just have to get.
Over GPIO.
Yeah, that's interesting. I feel like it would be possible to get it to work because of the way that you would set up Octoprint to
Mm-hmm.
talk over GPIO would be the same way you'd set up Quinly to talk over GPIO.
Like, it's still serial communication.
Mm-hmm.
Yeah. So I think it would probably work if you wanted to try that, Ben. That'd be interesting.
Yeah.
I would be very curious to know.
Yeah.
Yeah,
Cool.
interesting.
Thanks, Dominic. Oh, you guys might not actually know Dominic. Yeah, were you on one of our previous streams at the new office, right?
Yeah, in the background.
In the background.
Yeah, my voice has been here before.
Yeah, yeah.
There we go.
Yeah, he's taking Steven's place because Steven's gone on summer vacation.
Yes, lucky.
Lucky. Yeah, I know.
So I think that's about it for the stream.
Yeah, that's pretty much it. Those of you who did participate in the challenge, if you haven't already sent us photos, send us those and claim your
Prize.
filament prize. Yeah, otherwise, make sure before you guys leave, hit the like button, smash that like button.
Yes.
I think that's what you're supposed to say.
Yes.
Yeah, ring that bell.
Oh,
Yeah, ring the bell, hit subscribe, share everywhere.
we
if you liked
had our
it.
goal. We wanted to be over 300 by the
Oh yeah,
stream.
that's
We
true.
forgot. Yeah,
We
let's go, guys.
we hit our subscriber milestone of 300. Pretty exciting.
That's pretty hype.
Right after the last stream,
Oh,
and we're already
yeah.
at 316, so that's awesome.
Thanks, guys. There we go.
I will check that out, Ben. The Panda Pi sounds interesting.
Yeah.
Because Raspberry Pis are in short supply. Like, as a company, we can't even buy them anymore
Okay.
because
That'd be cool. If
they
we could
just don't
check that out.
have enough. So if Panda Pi is looking to solve that, I would love to.
Mhm.
Maybe I'll talk with you more about that on Discord if you're in our Discord. Oh yeah, it looks pretty good.
Cool.
This is cool. 64-bit 3D printer controller. Oh, I
Let's
guess that
go.
makes sense.
Mm.
Interesting.
Okay, we gotta look.
Thank
into
you
that
for the tip.
one.
How many people ended up completing? I think we're still counting up the entries. It was a lot of parts though.
Yeah, so it's
Definitely.
pretty fair that
Yeah, if they weren't
people didn't
using
really have the capacity.
if they weren't using
Quinly.
automation, it would have definitely been a bit of a challenge. Yeah, we plan on doing a much larger version of it, maybe 1.5 times scale or
Yeah,
even
that'd
two
look nice.
for a background. And maybe we could even go for the hexagon style.
I think that'll look sick. I like that.
That might look pretty cool. Yeah.
Hexagons.
Hexagons, technology.
I don't know why they always do.
There's
look
some like
special.
strong association with technology.
Yes.
Yeah. I guess it looks more technological than the squares.
It does. Squares are a bit boring sometimes.
Yeah.
Which is fair enough.
Yeah, fair enough. Okay. So Yeah, for those of you just joining at the end, a bit of a quick recap. Um, we talked about uh, the results of the print challenge and how internally what strategies we used to print nearly 400 parts. It was definitely far more than we had anticipated doing,
Yes.
so we're gonna have fun assembling the rest of them. If you want to show the boxes,
Yes. We
um,
got a lot more. Oh my
oh,
goodness,
it's okay.
sorry. the, the shelf parts.
Yeah,
And then we also have a bunch of the connecty parts.
connector parts. So many left to assemble. This is
I
only
know.
1/4 to 1/3 of everything that we put
Yeah.
together. But uh, just wait for you to put the
Yeah,
box.
I'm sorry,
No
guys.
worries.
Ta-da.
Yeah. So in printing nearly 400 parts over the 6 days of the challenge, um, we learned and used a lot of strategies from our production in order to get the most out of the 3 Quinlys we had set up. So I guess at a high level, it was um, it was doing small batches,
Mm-hmm.
5 for the rods and 4 for the shelf, the flat shelf parts. It was printing one at a time for the shelf parts because that saves retraction. And then it was also doing trade-offs between um, printing very hot and at a very high layer height
Mm-hmm.
and part tolerance. And what we learned was we went a little bit too hard on the speed, ended up with way more parts than we needed, um, and also could have improved a bit on tolerance.
Yes.
And that just highlights the importance of when using 3D printers for production, because every part is unique, you have to run a sanity check, run a test. Are the parts I'm getting off after the first couple cycles, are they good? Are they within the tolerance I need? And making that trade-off or sacrificing potentially print speed for better tolerance that fits in your whatever your requirements are.
Mm-hmm.
Ben, are you in our Discord? If you are, I might send you some questions about the panda pie because it looks really cool.
Mm-hmm.
But we'll talk about that later, I guess. Yeah. And for those of you who aren't in our Discord, definitely recommend joining because there's interesting discussion there every day. And if you're interested in getting your printer to run more like a production machine or just to save you time and run on its own with Quinly, definitely join and ask around in there how people are using it, or ask our staff who's also all in there. All right, I think that being said,
Yeah.
we'll
Wrap things up.
wrap
Yeah.
things up. There's no stream next week.
No,
No stream next week,
no stream next week,
but a stream after that.
exactly.
Okay.
There we go.
So just keep an eye out. We plan on doing more videos as well. So stay subscribed because we're planning to do a couple interesting videos over the next couple of weeks.
Really cool.
Yeah. All right. Thanks everyone for
Thanks,
watching.
everyone.
We'll see you
Next
in
time.
next time.
Not next week.
We'll see you next time.